What's the difference between a SQL and NoSQL database? Let's talk about it. Before diving into discussing SQL or NoSQL, let's first clarify what exactly is a database. To really understand databases, it's important to know the fundamental differences between data and databases. Data refers to individual pieces of information, for example, images, videos, text, or any form of information. And this information can be either processed or stored by a computer program. Database is the organized collection of information. It's set up in a way that makes it easy to store, find, and manage data efficiently. So the two main databases, SQL and non-SQL. So what do those words stand for? SQL stands for Structured Query Language, and the word query is a request for specific information from a database. And NoSQL, this stands for not only SQL, but some call it non-SQL. This is saying NoSQL databases aren't just about using traditional way of SQL. So for the first main difference, data model, a data model defines the structure and relationships of the data stored in the database. So for SQL databases, it uses a relational data model where data is organized into structured tables with rows and columns. What makes it relational is that you can connect or relate information from one table to another. The data is consistent by enforcing rules. Here is what a SQL database looks like. The data is organized into tables, and in this example, it uses a bookstore. The data is divided into 3 different tables. The first table contains information about the books, including the book ID and title, and the second table holds the author's information, including their ID and name. The third table is for genres, containing the genre ID and the genre name. You can see the connections between the tables. You can now see why they call it relational, because the tables are related. And I got this example from ChatGPT by just quickly typing in how does a SQL relational table database looks like. NoSQL databases use various data models, such as key values, documents, or graphs. They allow flexible data storage and do not follow the strict rules of organizing data into tables, making them non-relational. Here's a variation of a graph in NoSQL database. I know it might seem a bit overwhelming at first glance, but in this graph, there's arrows pointing in multiple directions towards employees and departments, indicating who reports to whom and which department employees belong to. As you can see, it's not as structured as a SQL database with fixed tables. Instead, it stores data in a flexible format, making it non-relational. But this offers a straightforward solution that's really fast. Second difference is scalability. This means a system's ability to handle increasing amounts of data, users, or tasks without slowing down or crashing. For SQL databases, it's traditionally designed for vertical scalability, meaning you can increase the capacity of a single server by adding more resources or storage. However, there's a limit to how much you can improve the performance of a single server through vertical scaling. Let's take a look at this image here. In vertical scaling, a single server upgrades up by adding hardware, like adding more memory to handle more tasks and data. But it can hit a point where you can't upgrade the server anymore, and it might struggle to handle a lot of work, leading to slowdowns or crashes. For NoSQL databases, it's designed for horizontal scalability. This can handle lots of data and users by adding more servers, which spreads out the workload across multiple machines. This makes them great for big applications that need to handle a ton of traffic. Here's an image of how NoSQL database scale horizontally. You can see how it has multiple servers, and this is to keep the system fast and flexible as it grows, and has no limits like vertical scaling. However, needing more servers can increase the cost, and coordinating the data between them can be tricky and lead to network problems. And consistency and transactions. In databases, consistency ensures the data is always correct, while transactions ensure that changes to the data happen rapidly and completely. For SQL databases, they use something called ACID transactions. which basically means they make sure changes to the data are done carefully. ACID stands for atomicity, consistency, isolation, and durability. These transactions ensure that when you change something, it's either all done properly or not done at all, so you can trust the data. NoSQL databases focus on being fast and being able to handle a lot of data. Even if it means they might not always keep everything instantly consistent, instead they aim for eventual consistency, which means eventually all the data will be the same across the system, but there might be a small delay before that happens. Now that you know three main differences between SQL and non-SQL, we'll use the example of an app. So for SQL databases, let's take a to-do list app for an example. In this app, you can create tasks, set due dates, and mark tasks as completed. These tasks are stored neatly in a structured way within the app's database, making it easy to find and manage them whenever you need. An example for NoSQL databases, imagine a social media app like Instagram. In this app, you have users who post photos, write comments, and like posts. Now, instead of neatly organizing all this information into a spread table like traditional databases, a NoSQL database might store everything together in a more flexible way, kind of like a big digital filing cabinet. I hope those examples gave you a better understanding of the difference between a SQL database and a NoSQL database. Thanks for watching the video. Don't forget to like, comment, and subscribe to my channel. See you next time.